If you are new to the channel, then subscribe the channel and press the bell icon for further notification. Okay student, welcome you all to this new lecture in machine series. So today again we will be solving 5 questions starting from question number 131 to question number 135. Okay, then let's try to solve these 5 questions. Okay, in question number 131, 3 single phase transformers are connected to form delta star 3 phase transformers of 110/11 kV. The transformer supplies 11 kV, a load of 8 megawatt at 0.8 power factor lagging to a nearby plant. Neglect the transformer losses, the ratio of the phase current in delta side to start side. So it is connected in this fashion, 3 single phase or a 3 phase, it doesn't matter. The connection is of this fashion, start to delta side. And this ratio is 110 kV is to 11 kV. This is the ratio between line voltages. You have to be careful, it is not the turn ratio. So now what they are asking here, it is supplying, this side is supplying 8 megawatt load start side to a nearby plant, and the phase current ratio of the single phase transformer connected to delta star 3 phase, the transformer supplies 11 kV, 8 megawatt load. So if I think this side is connected to load, it is 8 megawatt load, 0.8 power factor lagging. Okay, so what is the current here? Always I told you, in this type of cases in transformer you always take care of this phase current. What is the phase current here? That corresponding phase current will come here. So what is the phase current here? I phase will be equal to, in star, I line equal to I phase. So you can directly write I phase equal to IL, that is 8 megawatt, 8 into 10 to the power 6 divided by root 3 VLIL cos phi you can apply, or you can apply 3 VP IP cos phi. In case of VP, then you have to change it to, because 11 is your line voltage, but if you are writing in line, so it is root 3 VLIL and then it is 0.8. So if you do this one, you will find whatever value, suppose x, because exact value is not required. Whatever they are asking the ratio, just to think it is x. So if it is x here, so accordingly as per ratio it will come here. This is also phase, so you can directly get this value. This is suppose secondary side, so your primary side phase current will be equal to, you multiply that by this ratio. Now what is the ratio here? Line voltage is 110, so this is also 110 phase voltage. Here it is 11, so 110 is to 11 by root 3. So this is the ratio, actually 10 root 3 is to 1. So if you bring your voltage from this to this side, it will increase, so your current should decrease, so it will divided by 10 root 3. So what is the question they are asking? Delta side to start side, means this delta side is this one, this is to start side. Because only ratio, that's why I am not calculating value. You can put this value, there is no issue. So it is 1 is to 10 root 3. That is your option A. In an ideal transformer has an inductive load element as shown in the port 2. So what is the equivalent inductance in port 1? So you have to refer from this to this side. So you know, if your Z is equal to 2 pi FL, so how Z is referred this side? So Z dash will be equal to, if I take n is equal to 2, so it is higher voltage side. So if you go from this to this side, it should increase. That means you are multiplying by 2 square. That means you are multiplying by n square. So that will be n square into Z. So it will be, you can write it 2 pi F n square into L. It is actually n square 2 pi FL. So if I change it to this, it is n square. So actually your L, original it is L, now it is look like L dash. So your L dash is nothing but n square into L. So that is your option B. You can think if it is a C, that will be different. It will be divided by, in that case. So you have to see Z will be multiplied by n square. Accordingly you see what is happening in your L. Question number 133. A 3-phase 3-winding delta delta star 1.5 this 6.6 transformer is energized from AC main on 1.1 kV side. It supplies 9 kVA load at 0.8 power factor in 6.6 kV side, 300 kV at 0.6 power factor from 400 kV voltage winding. The RMS line current drawn in ampere in 1.1 side of the mains. So it is of this fashion, star, delta, delta and then star. So primary 1, 2 secondary. This side is 1.1 kV, this side is 6.6 kV and this side is 400 volt. So some load is connected here. It is 900 kVA, 0.8 power factor lagging from the 6.1, and some load connected in this winding, 300 kVA, 0.6 power factor lagging. So what is the current it is asking? This current I1. So obviously I1 has two branch. One I2 dash will come from this side. So I1 will be I2 dash plus I3 dash. These two currents will be reflected. Now from here to here, again I told you, you just say this, what is the phase current here? The phase current here. Accordingly you convert it into line current. So it is actually I2 line, I1 line current they are asking. So what will be your I2 dash? First you take your phase current. So first you calculate I2 phase. So what will be your I2 phase? So what will be I2 phase? It is, because it is phase, so I will apply 3 VPIP. So it is 900 into 10 to the power 3 VP. What is VP? this one. So in this star side, this is actually, I am talking about 2 is this one, 3 is this one, 1 is this one. So 2 means delta. So in case of delta, what is V phase? Same is V line. So you can put it 6.6 into 10 to the power 3. So whatever current it come, that much at an angle of minus cos inverse 0.8. So what will be then I2 dash P to reflect this one as per the ratio. What is the ratio? Here is the 1.1, it is, so it is, the ratio is 1:6. If you are bringing your voltage, then it is reducing, so current will increase. So it will be 6 into whatever you have got at an angle of minus cos inverse 0.6. And what will be its line contribution? I2 dash line, you multiply by root 3 into whatever you got here from here. So if you do all these things, I think you will get it 472.4 at an angle of minus 36.86. Similarly, you come for I3. So first you do I3 phase. Always calculate phase, then you convert to line. So it is again, here it is 300 kVA, so 300 into 10 to the power 6, 3 divided by again 3 Vp Ip, 3. What is Vp here? 400 is a line voltage, because it is star, so it should be 400 divided by root 3. So it is Vp. So what is here, if you convert it your at an angle of minus cos inverse 0.6. So what will be your V3P dash, this one multiplied by the turn ratio. Again, what is the turn ratio here? Here it is 400 by root 3, 1.1 या फिर 1100 is to 400 by root 3. So if you are going from this to this side, voltage is increasing, so current should reduce. So you divide it by more, multiply it by less. So current will getting reduced. Now what will be I3 line dash? Whatever you got, that multiplied by again root 3, because you got this phase current corresponding, so again it will be multiplied because it is delta side. So if you multiply this one, I think you will get it 157.56 into at an angle of minus 53.13. So therefore your I1 will be summation of this I2 dash line plus I3 dash line. If you add these two, you will get your answer 625.19 at an angle of minus 40.9. That is your answer. Now if you come to question number 134, if the primary line voltage rating is 3.3 kV start side of a 25 kV start to delta transformer, turn ratio is given 5:1, par phase turn ratio, that means actual turn ratio is given. Then the line current of the secondary side is, so it is start to delta, and this side it is given 3.3 kV, the turn ratio is 5:1, actual turn ratio. Then the line current in the secondary. So what is the voltage here? If you apply 3 kV, so this side it is 3.3 by root 3, because par phase we will be calculating. So that it is 5:1, K means 10 to the power 3. So this side voltage will be, suppose this is my V1 par phase. So what will be V2 par phase? 3.3 divided by into 10 to the power 3 divided by root 3. That divided by 5, because turn ratio is 5:1. For 5, 1 volt will come. So this is the voltage. So if you do this one, it is 381.05 volt. So what will be I2? They are asking phase or line. Let us see. They are asking then the line current. Okay, so the line current will be, it is 25 kVA, 25 into 10 to the power 3 root 3 VLIL. Now in the delta side, whatever phase voltage, that is your line voltage. So VL will be also 381.05. So this current will be 37.878. That is your answer. Next, if you come to question number 135, a single phase 100 kVA 1000 by 100 volt 50 Hz transformer has a voltage drop of 5% across its series impedance at full load. Of this, 3% is due to resistance. The percentage regulation of the transformer as full load at 0.8 power factor lagging. So this drop is given, IARA, total IAZ is given in parts of in per unit, it is 0.05, and IARA is given. IARA is given 0.03. So what will be IAX? So I think you know, this square is equal to this square plus this square, because Z drop is this one, RA drop is this one, X drop is, this is IA into R, this is IA into X, this is IA into Z. So this will be under root Pythagoras theorem 0.05 square minus 0.03 square. You know 5/3 will give you 4. So it will be 0.04. So everything is in per unit. So once you know per unit, I think you can use the formula of regulation. It is IARA into X cos phi, that is 0.03 into power factor they have given 0.8 cos phi, IARA cos phi plus IA excess sin phi into sin phi is, if it is 0.8 then it is 0.6. So if you take product of this one, I think you will get the answer 0.048. So if into 100 if you do, it is 4.8%. That is the regulation. If you like the video, then press the like button and please give your valuable comments in the comment section.